Let me put this link in because this will consist the notes for today. All right. So if you look at the message box, the size here, look at the message box. Do you see that link? Click on that link. You should be able to see my notes. Can see, right? All right. So you should be able to see the notes. Yeah, that's the one that I'll be going through today. Okay. Any one of you cannot access this flipbook, you should be able to see something like this. Let me show you similar screen. I still prefer Zoom, you know. Still prefer Zoom. Google Meet is tough. Okay, so you should have all this. Now you can print this out and then copy down the notes yourself. All right. Or later on, because I didn't send you these notes early enough, right? So you will not be able to print out at this moment. I know some of you can. Yeah, like Evan can run to the printer and immediately print out, I know. Okay, but it's not necessary. Okay, I'll be sending you the one with the notes also later. Cannot do online one. This one, you just download PDF. I have not mastered that skill, you know, type the notes in, you just go and type in your answer there. Have not. I will do that next time. Okay, so we are starting with this topic. This topic is not unfamiliar, okay, because you have done this in P6. Okay, although it's like 2 years ago, but you should know forces. Yeah, so what are the types of forces? Okay, of course, you know, gravity, gravitational force, then you have frictional force, magnetic force, etc. Right now. So forces in nature also can affect us. Forces in nature, that means what? Okay, those natural disaster kind of thing. Okay, so how it affects us, you need to know, you must be aware. It's inside the textbook, but today we are focusing on effects of forces, okay? And of course, we are going to do the measurement of forces, okay? What is friction, ways to reduce friction, etc. And then we will do gravitational force. And you are required to do some calculation on my notes, okay? Fill up those blank areas. Then we will go through the worksheets, okay? Now, of course, we are not finishing the whole topic just in one lesson, okay? We will be spending some time on this chapter. So, learning objective, you need to state that forces, okay, can change the state of rest or motion of a body. So, in primary school, you say you can make a stationary object start moving, cause a moving object to stop moving, etc. Right? Not change direction, change speed. So, all these you are aware already. Forces can also change the size and shape of an object, okay, or a body. Then it can bring about turning effects in objects. What's the meaning of turning effect? For example, liver, okay? For example, a Milo tin. How many of you have those huge Milo tin at home? Then you need to open the lid. It's so difficult to use your hand to pull out, right? What would you use? What would you use? Don't use your fingernails, I have students who say fingernail. Sure break. No, the Milo tin. You know what is Milo tin or not? Y'all are 3-in-1 Milo only, right? Never use Milo tin one, huh? You all don't use this kind. Let me show you how you do. So pampered. Everybody use 3-in-1. I'm talking about this time. Jared, yeah, spoon. And you use can opener. Okay. Some parts of can opener, right? Okay, this is the tin. So you want to open the lid. Very difficult. You cannot use nails on. Your nails will all break. You are supposed to use like fork or spoon or scissors, you know, something with some leverage. Now, so when you hold that spoon, right, and then you press it down at one end, the other end that is in contact with the lid will tilt it out, right now, and then your lid is open. So that is the meaning of this turning effect. Okay, there's a pivot point. Someone mentioned pivot point, right? Yes, Nikki. Yes, the pivot point, it helps. It helps actually. So exert pressure on objects, Okay, that's what forces can do also. Now, remember contact forces? This is not new, right? We talk about contact forces, non-contact forces in P6 as well. Do you still recall? Okay, contact forces like frictional force, non-contact forces will be gravitational force, magnetic force. So we are talking about these three forces today. Okay, then you have to predict their effects on an object. How tides are caused by gravitational interaction between the ocean and the moon. Yeah, that's how tides arise. Then you must know the difference between mass and weight. Okay, then make measurements of length, time. You must also make measurements of like mass and forces, etc. All right, let's continue. Sorry, this is the worksheet. I need to show you the notes now. If you all have your own printer, you can send it for print. Otherwise, you just look at my screen first. Where is my notes? It's here. Yes. Okay. Can see this? Give me 1 minute. Let me end the show here first. All right. So if you can see this, right? Okay, this is Word document now. So I'll be typing or writing on this. Now, again, if I were to show you, you can see, okay, learning objective, it is pretty much the same as what I have talked to you about just now. Okay, what you don't see yet is actually pressure and the forces in nature. Okay, so these two we are covering in another lesson. All right, so today, yeah, you just focus on this part. And the notes that you have received, right, is only for the forces part. Pressure onwards, you don't have yet. You are going to receive it before next Tuesday. So I will be sending to all of you. Okay, so with that, that means I will need all of your handphone number. Then I can put the group chat. Okay, now forces in everyday life, what are the effects of forces? I have already explained to you just now, right? So you can tell it's actually these 4 points. So I'm not going to write that down. I'm going to, in fact, quickly run through, all right, these notes. So you are going to copy these 4 points yourself. So Hannah, you can annotate, right, on your own, but don't annotate now. Yeah, okay, like add it on to the same. Oh, you can do that? That's very good. Good, good, good. Yeah, I'm happy for you if you can do that. Now, so this part here, I will annotate. Where's my pen? Okay. I use draw. Okay. Forces bring about turning effects in objects. So I mentioned just now, right? So what is this kind of device known as? The device that turns when a force is exerted is called a lever. Okay. So the point about which the lever turn, like the spoon, right? Yeah, the point where it is at, and then it allows it to move, right? Okay, is called the pivot. So this is the pivot that was earlier mentioned. Okay, so write down these notes. Okay, those of you who can write down, write down. If you cannot, don't worry. Later at the end of class, I will send you this copy, or I can also send it in our group chat. Now we use something to measure force. What do we use? In fact, we use spring balances. This is really how we measure force. Now there are 2 types of spring balances. Okay, this type, right, you put that object on the top, okay, and then it presses down, right? So this is known as the compression spring balance. Okay, why is it called a spring balance when you look like this? Because there are some springs inside. Now, in this one, okay, you are hanging the object on this hook. So you are actually pulling it downwards. It's an extension. So this is the extension spring balance. To be very, very exact, right? If I want to name this particular instrument, this extension spring balance has a name. It's called the Newton meter. Okay, Newton meter. So it measures forces, and the units of forces is actually the newtons. Oh, am I too fast? Am I too fast, children? And thank you for telling me. If I'm too fast, let me know, okay? Yeah. All right. But I think the next time, if I send you all the notes earlier, it will be better, right? Not? Yeah, especially if you all need to copy. But Ange, don't worry, you don't have to copy this one yet. I can send you the one that I've annotated. Okay, Ange? Yeah, the rest of you following? If you all are following, give me a thumbs up, please. If you are following, give me a thumbs up. Okay, good. Yes. All right. Okay, SI unit of force is the Newton. Okay, so you spell it this way. And then the symbol is capital N. Right, so this is SI unit of force. What are some forces around us? Okay, so you broadly classify them as two types of forces. So we talked about the two types of forces just now, right? The one that is touching one in contact. The other one is not in contact. So we call them contact and non-contact. So Ange, I think you pay attention first. Don't copy anything. All right, I want you to pay attention. Yeah, if copying all this will affect your focus, don't copy. The rest of you, same thing. Don't copy. Then I will go through review like this. Okay, then after that, I can send you the annotated ones. Okay, a contact force is a force that acts when objects actually touch. So friction is a contact force. We know that. All right. Then non-contact forces like magnets, right? They don't have to touch each other, but they can attract each other. Okay, so they act from a distance. Okay, so what can we say? Magnetic, right? Magnetic and gravitational forces. Okay, are the non-contact forces. This one is P6 content. You all know that, right? This contact and non-contact forces is P6 content. Right now, Nikki, do you recall? We learned this in P6. Yeah. So friction acts whenever one surface rubs against another surface. So that is friction. Remember, we always talk about friction between two objects that are in contact. All right. So when you all talk about friction, remember I have said many of you didn't answer the question properly because you did not talk about frictional force between the two objects. Yeah, correct. When you're rubbing hands, yes, there is friction in between, okay, between the two hands, right? That produces the heat. That is one good or bad effect of friction lah. Later you will talk about it. Now, the surfaces, okay, may be solid, liquid, or gases. Now, friction always opposes motion of an object, okay? So it's always acting in the opposite direction. Movement, yes, movement also can because they mean the same thing. In science, so they don't really mark for language, you know. Your is, are, was, were, wrong also never mind. You know what I mean? Not. So if you say atoms is, nobody's going to mark you wrong, right? It should be atoms are lah. Okay, in science, they don't mark you for grammatical error or any language relevant related, unless it's spelling. Spelling, they are particular. So you spell atoms, you cannot spell as A-T-U-M-S. They will mark you wrong, atoms. So there's no such thing. Okay, it must be atoms. Okay, secondary school is different from PSLE. Remember PSLE, I told you all, right? Okay, if you write down A-T-U-M, atoms sounds a bit like atoms, right? The atom, they still mark you right. But in secondary school, spelling errors are not tolerated. Okay, they will mark you wrong. Must remember this. Now, let's go on. Okay, friction can be useful. So it helps us to walk without slipping. Okay, so we don't slip and fall, right? So you can write down as many examples as you want. All right. And then friction allows what? Allows us to stop moving. Okay. Then allows us to write on paper or surfaces. Yeah, so these are some of the advantage, you know, of friction. Even Nikki, you talk about rubbing hands, right? So the context is also important. say we are in a cold country, you are feeling very cold. So you are going to